Hello, welcome to Chemistry Untold. So what we're going to speak today will be we are going to study about batteries, cells and their reactions. This will be totally shortcuts. I'm not going to explain you the details stuff of these reactions, how to by heart them, how to keep them in your mind. So we'll be starting with the very first, that's called as a Daniell cell. Now you all can see this is the structure, this is the construction of your Daniell cell. What you have got are two containers. One of them will be containing a zinc rod and dipped in a zinc sulfate solution. Other will be containing a copper rod dipped into a copper sulfate solution. Always remember, this is going to show oxidation and this is going to show reduction. So you can write down the reactions, very simple. Oxidation simply means anode and reduction simply means cathode. So the reactions will be very simple. So anodic reaction will be, your zinc coming out into the solution giving you zinc plus 2 ion. So this will be zinc solid coming out into the solution giving you Zn2 plus ion. That will be your aqueous plus 2 electrons, as it is an oxidation reaction. That cathodic reaction will be, on cathode, the reaction is copper plus 2 from the solution will be accepting electrons and will be getting discharged at the rod. So the cathodic reaction can be copper 2 plus from your aqueous solution will be accepting 2 electrons and will get discharged over there producing copper solid. So the overall reaction which will be over here will be 2 electrons getting cancelled. Your zinc, that will be your solid, plus your copper 2 plus ions from the solution will be getting converted into Zn2 plus ion, that will be in aqueous plus copper solid. As simple as that. The next will be SHE, that's standard hydrogen electrode. Now the construction of SHE is very simple. What you have got is a container which will be containing HCl solution that has to be 1 molar because it's standard hydrogen electrode. You will be having a platinized platinum plate which will be attached to the connecting wire. It can be made up of copper or it can be made up of platinum. This platinized platinum plate has got a very high affinity for hydrogen. It absorbs hydrogens on its surface. So as soon as you pass hydrogen from this inlet, the hydrogen is gonna get adsorbed on this platinum plate, and this hydrogen, this blue color particles are nothing but adsorbed hydrogen. So I can write over here, this are hydrogen, that is nothing but gas which is adsorbed over there. So it will be working like a solid, as we all know that we cannot make an electrode of a gas. So this is an indirect method of making a solid electrode out of a non-metal which is a gas by making them adsorbed on a platinized platinum plate. Now what should be the condition? Your hydrogen has to be pure, it has to be dry, and it should be pumped at 1 atmospheric pressure. As we all know, what are the drawbacks of this SHE? The drawbacks of this SHE are that you cannot make an 1 molar HCl solution for a long time, as HCl will evaporate. You cannot get pure and dry hydrogen gas, and it cannot be pumped at 1 atmosphere for a long time. So these are some drawbacks of SHE. Please do remember them. It's one of the most important questions which is asked in your HSC board exams. Now what will be the reaction? Since we know hydrogen electrode can do oxidation as well as it can do reduction. So it can act as an anode as well as it can act as a cathode. So what will be anodic reaction? So let us start with anodic reaction first. Anode. So we all know anode simply means oxidation. So who will be doing oxidation? Obviously hydrogen will be doing oxidation. So simply H plus in the solution cannot do oxidation. So oxidation will be done by these particles which are adsorbed on platinized platinum plate. This is H2 molecule. These H2 molecules will lose their electrons and they will be coming out into the solution giving you H plus ions. So what will be the reaction? The reaction will be H2, which is a gas, or you can write solid since it is working as a solid right now. It will be getting converted into 2 times H plus ion, that will be giving you aqueous, plus it will be losing 2 of its electron. Okay, this is anodic reaction, or you can say an oxidation reaction. Since your SHE is a reference electrode, it can even undergo reduction. So it can even give you a cathodic reaction. So what will be the cathodic reaction? The cathodic reaction will be simply, now cathode means gaining electron, yani reduction. So who will be doing the reduction over here? Obviously Cl minus cannot do your reduction. So the reduction will be done by this H plus ion which are already present in the solution. This H plus ion will be moving towards the platinized platinum plate, will be accepting electron and will be getting stuck over there as in the form of H2 gas. So what will be the reaction? The reaction will be 2 times H plus will be accepting 2 electrons and will get converted into H2. Now if you look very carefully, I can write over here gas. If you look very carefully, this reaction is simply a reverse of upper reaction. Am I correct? So how you can remember? What should be the shortcut? The simplest shortcut will be you write H2, which will be your gas, getting converted into 2 times H plus 2 electrons, as well as you can write down this. This arrow will be showing you oxidation, and this arrow will be showing you reduction. So I can say this arrow will be nothing but for cathodic reaction, and this arrow will be nothing but for anodic reaction. So you just remember this reaction, H2 giving you 2 times H plus 2 electrons. If it is going in this way, that's an oxidation reaction. If it's coming in this way, this will be a reduction reaction. That's the simplest trick you can remember. You don't need to by heart all the stuff. Am I correct? The next cell which you have got is your Kelomal reference electrode, which is a secondary reference electrode. Now let us start with the construction of Kelomal electrode first of all. You will be having a glass tube. It will be having an inbuilt salt breeze present over here. It will be completely sealed. You will be having pure mercury in a liquid form which will be placed at the bottom. You will be having a paste of Hg2Cl2, that's also called as Kelomal, mercurous chloride. You will be having saturated solution of KCl. The EMF of this cell will depend upon the concentration of KCl you are using. So the EMF may vary with the temperature as well as with the concentration of KCl that you are using. Okay, so what will be the reaction? Since it is a reference electrode, it can even work as an anode, it can even work as a cathode. So it can undergo oxidation as well as it can undergo reduction. So let us say we have connected it with one of the electrode which is undergoing an oxidation reaction. So oxidation reaction simply means, let us say we have got a zinc present over here, we have got a zinc sulfate solution present over here. So zinc will be coming out giving you Zn2 plus, and electrons will be produced on this electrode. Since this electrode is undergoing oxidation, this reference electrode has to undergo reduction. So what will be the reaction shown by this? So let us say it is working as an cathode. So obviously it will be showing you reduction reaction. So what will be the reduction reaction? The reduction reaction will be, now reduction simply means gain of electron. So obviously mercury present over here will not be accepting electrons. Since mercury is a metal, it will obviously love to lose electron, get converted into a cation. The Cl minus over here already has got a Cl negative charge, so it will not be accepting electron. We have got KCl solution which will be K plus and Cl minus. K plus will not accept electron since it is a highly reactive metal. It tries to stay in K plus position. Cl minus again will not be accepting electron. So the only option left for the ion to accept electron will be Hg plus present over here. So this Hg plus present over here will be accepting the incoming electron from this rod and will get converted into pure mercury. Only the ions left will be Cl minus. The Cl minus will be present over here. So what will be the reaction? The reaction will be simple. Hg2Cl2, where you have got your Hg in +1 oxidation state, will be accepting 2 electrons and will be getting converted into mercury, will get converted into Hg, that will be with 0 oxidation state, and that to 2 times mercury, leaving behind 2 times Cl minus. Since Cl minus has got nothing to do with this reaction, they are just working as a spectator. So this will be the reaction as a cathode, or you can say a reduction reaction. Now let us consider, instead of zinc, there is a copper plate which is placed over here, and you have got copper sulfate solution placed over there. So this will be your copper rod present with copper sulfate solution. So obviously copper will be doing reduction over here. So this will be a positive rod. Now since this is a positive rod and since over here it's reduction taking place and your Kelomal is working as a reference electrode, it has to undergo oxidation reaction. So when I say oxidation reaction, it simply means it will be working as an anode. So what will be the reaction? Oxidation reaction. Now again the question arises, oxidation simply means loss of electron. So who will be losing of electron? Now the only option left will be either Cl minus or either Hg. Now Cl minus will not lose its electron since it's an electronegative element and it tries to stay as Cl minus. So the only option will be Hg. So Hg from this liquid layer will be coming up, it will be losing electrons and it will get converted into Hg plus. Now Hg plus cannot stay as Hg plus, so it will get combined with Cl minus giving you Hg2Cl2. So what will be the reaction? The reaction will be very simple. 2 times mercury, which will be in liquid state, will lose electron and will get converted into Hg plus. Am I correct? Will be giving you 2 electrons. Now the problem is Hg plus cannot stay, so it will be clubbing up with Cl minus giving you Hg2Cl2, and obviously since Cl minus was present over there, this 2 times Cl minus will be again taking part in the reaction. They will be present as a spectator but they will not take part in the reaction. So if you look very carefully, this cathodic reaction is simply a reverse of oxidation reaction. So how you can remember? You can remember in a simple way. Let us say it's Hg plus 2 times Cl minus, this will be 2, giving you the simple arrow will be Hg2Cl2 plus 2 electrons. So if this arrow is there, it simply means it's working as oxidation, or you can say it's working as an anodic electrode. If the reaction is reversed, it will be working as your cathode, or you can say reduction is taking place. So simply you need to remember this reaction, and by remembering this reaction you can write down oxidation, or you can write down reduction. Now the thing to remember over here is, the trick to remember over here is, if your Hg2Cl2 paste is getting shrinked, that simply means mercury is accepting electron, and since mercury is accepting electron, it is undergoing reduction, and since it is undergoing reduction, the electrode which was attached over here would be undergoing oxidation. So if it shrinks, it is undergoing reduction. If it expands, it is undergoing oxidation. I hope these tricks are useful. Okay, the next cell, the next battery which we are going to study will be called as a dry cell. It is also called as Leclanche's cell. Now this is a primary voltaic cell. The primary voltaic cell simply means that once it is exhausted, it cannot be reversed back. And the secondary voltaic cell simply means the one which can be charged or recharged. The examples can be lead accumulator battery or lithium ion battery, which are used in your mobiles. So we'll be studying dry cell, or you can say Leclanche's cell. First of all, you should know construction, or you can say diagram, because construction diagram is asked in your board exam, not the reactions are often asked. So it will be constructed somewhat like this. Let us say I have got a container. This container is made up of zinc. So this will be a zinc container. Let me draw somewhat like this. Let us say I have got a carbon rod which will be placed in middle over here. Let us say, I have packed this with wax over here. So this will be your wax coating, and this will be your carbon rod, or you can say graphite rod. This will be your zinc container. Obviously it will be in solid state. You will be having a separation, a porous separation, or you can say a cloth which will be present over here. Inside this cloth, you will be having a paste of MnO2. Now, I will be telling you why this MnO2 is used. Between this cloth and between this container, you will be having a paste of a mixture of, let us say, zinc chloride plus ammonium chloride, NH4Cl. Now, this ammonium chloride will be in larger quantity and not ZnCl2. So, what will be the reaction? Let us say we are connecting a wire from here, that is from your container, and let us say this is connected with a bulb present over here. So this bulb is a tungsten wire bulb, and this is just to check whether the cell is working or not, whether the electricity is flowing or not. Let us say this will be connected to this. Now what will be the reaction? Now the first reaction that will be taking place will be at this rod, this container. Your atoms of zinc will be coming out into the solution as Zn2+. So what will be your oxidation reaction? So this will be your oxidation, since zinc are losing electron, so I can say this is working as an anode. So since electrons are lost behind and Zn2+ is going, I can say this will be your negative rod. So anodic reaction will be Zn2+, that will be in solid state, will get converted into, this will be Zn, it will be getting converted into Zn2+ plus 2 electrons. Now since this Zn2+ is coming inside, you already have NH4Cl present over there. NH4 will be in positive oxidation state, Cl will be in negative oxidation state. This zinc will replace NH4 and it will pull chloride toward itself. So obviously when chlorine will leave ammonium, chlorine will combine with ZnCl2. It will combine with Zn, producing you ZnCl2. So this ammonium will be left behind. Now these electrons which were present over here, which were produced over here, these electrons will be traveling, and obviously they will get accommodated over here in the carbon electrode. Am I correct? This ammonium, whose chloride ion was forcefully occupied by zinc, this ammonium ion will be running towards this carbon electrode. It will be passing through the MnO2 solution. It will reach towards carbon rod. So what will be the reaction taking place over there? Since that will be a gain of electron, I can say it will be a cathodic reaction, or I can say it will be a cathode, or you can say it will be a reduction reaction. So what will be the reaction? Now let me tell you, ammonium NH4+ simply means you have got NH3 which is coordinatively bonded with H+. Am I correct? So you will be having 2 times NH4 plus. This 2 times NH4 plus will accept 2 electrons, and ammonium, out of ammonium you will be getting 2 times NH3 plus you will be getting 2 times hydrogen, or you can say you will be writing H2. What exactly is happening? These 2 ammonium molecules from here will be traveling. You will be having NH4 plus, you will be having NH4 plus. They will split into H plus, they will split into H plus, giving you NH3, giving you NH3. So this ammonia is produced over here. So this ammonia will be produced over here. The left behind will be H plus. This H plus will be accepting electron. They will club up together to give you H2. Am I correct? Now since you look over here, hydrogen gas is produced near this electrode, and if this reaction continues, there will be accumulation of hydrogen gas over here. So we need to kill this hydrogen, or we need to destroy this hydrogen which is produced over there. So for that purpose we have used MnO2 paste which is there. So as soon as hydrogen gas will be produced over here, hydrogen MnO2, that will be MnO2, will react with hydrogen, producing you Mn2O3 plus 2 times H2O. So you will be getting Mn2O3 and you will be getting H2O. This is also one of the reasons whenever you open a dry cell, you will be finding it a little wet or little moist. The reason is you are getting water molecule produced over there. So what will be the overall reaction? The overall reaction will be over here. This will be the overall cathodic reaction. So these are the 2 reactions that you need to remember. So if you look over carefully, whatever you will be having will be hydrogen getting cancelled. It will be 2 times NH4 plus 2 electrons plus 2 times MnO2 getting converted into 2 times NH3 plus Mn2O3 plus you have got 2 times H2O. So I'm repeating it again. What exactly is happening is you have got a zinc container, you have got ammonium chloride paste, you have got MnO2, and then at the end you have got a carbon electrode. Zinc will be coming out in the solution, leaving behind 2 electrons. These 2 electrons will be traveling, they will be coming over here, hence you will be getting a negative electrode over here. This zinc will pull away the chloride ions from ammonium. This ammonium will be left behind, it will be forming zinc chloride. This ammonium will travel towards carbon rod. At reaching carbon rod, it will get decomposed into NH3, leaving behind H plus. This H plus will accept electron, giving you hydrogen gas. Since hydrogen gas need to be destroyed, we have got MnO2. This MnO2 will react with hydrogen, giving you Mn2O3 plus water. I hope. So what about this ammonia? Where this ammonia will go? This ammonia, that is NH3, will be coming and it will be reacting with Zn2 plus, or I can say it will be reacting with ZnCl2. So 4 ammonia molecules will react with ZnCl2, giving a complex of NH3 4 times Cl2. I hope you are familiar with this. This is taught in coordination chemistry. It's a complex compound. So this is all about the working and construction of your dry cell. The next will be lead accumulator battery. So this will be the construction. The diagram given in the textbook is a bit complicated. So let me simplify this diagram for you people. Let us say I have got a container, and this container contains 2 rods. The first rod will be made up of Pb, that is lead, which will be in solid state, and this will be the atoms of lead. This rod will also be made up of lead. This will be also made up of lead. The only problem is you will be having a coating of lead oxide over here. So this is a coating of lead oxide, and that is nothing but PbO2. So you will be having an H2SO4 solution which will be present over here, and that is nothing but H plus as well as SO4 minus 2. So now there's a problem with this cell. This cell can work as a galvanic cell as well as this cell can work as an electrolytic cell. When it is working as a galvanic cell, it will be producing electricity, and whenever it is working as an electrolytic cell, it will be consuming electricity. Or in other words, in simple words, I can say it can produce electricity and then again it can be recharged. So let us start with the first reaction. Let us say it is working as a galvanic cell. This will be galvanic cell. So I can say this is nothing but discharging, as electricity will be produced on the cost of chemicals. Now let us say this is discharging. So let me connect over here a bulb which will be a signal whether the cell is working or not. So the first reaction that will be happening over here will be lead will be leaving behind 2 electrons and it will be coming into the solution as Pb2 plus. and it will combine with sulfate, giving you PbSO4. So what will be the first reaction? The first reaction will be anodic reaction, since oxidation is taking place over here. So oxidation. So the reaction will be Pb, that is nothing but solid, will be getting converted into Pb2 plus 2 electrons. This Pb2 plus will combine with SO4 minus 2, giving you PbSO4. So what will be the overall reaction? The overall reaction will be Pb getting cancelled. So this will be Pb plus, I'm not writing solid, SO4 minus 2 will be getting converted into PbSO4. Am I correct? So slowly this rod will be getting disappeared, since Pb is coming out in the solution and giving you PbSO4. Am I correct? So electrons are produced over here. These electrons will obviously be traveling to this electrode, since it will be developing a positive charge. How it will develop a positive charge? Simple. Hydrogen from this solution will be moving over here, and it will try to capture electron from this Pb rod. But since you have got Pb oxide layer over here, the reaction will be, that is acceptance of electron, that can be written as a reduction, or you can say it will be working as a cathode. So the reactions will be H plus and PbO2 together will accept electron, producing H2O as well as producing Pb2 plus. So the reaction will be, you have got 4 times H plus you have got PbO2 as well as you have got 2 electrons. This will be giving you 4H plus O2. This will be giving you 2 times H2O plus it will be giving you Pb2 plus. This Pb2 plus will combine with sulfate SO4 minus 2 ion, giving you again PbSO4. So this will be PbSO4. So the overall reaction over here will be Pb getting cancelled. So this will be 4 times H plus PbO2 plus 2 electrons plus SO4 minus 2 or 2 minus will be giving you PbSO4 plus 2 times H2O. That's all. So what will be the reaction? H plus PbO2 giving you water, giving you Pb2 plus combining with sulfate, giving you PbSO4. And slowly and steadily this Pb oxide layer will be getting disappeared, and here the rod will be getting disappeared. Once this chemical reaction stops, your cell will stop working. Now you have to recharge it. Now recharging means doing all the reaction in the reverse direction. So for recharging, what you will be doing over here will be connecting an external battery which will be having an EMF greater than the EMF produced by this battery, because you want to reverse all the reaction. So what you will be doing will be, you will be connecting negative rod with the rod which was working as negative in galvanic cell, and you will be connecting a positive rod with the rod which was working as a positive in the galvanic cell. So the reactions will be reversed. So I can write over here, this is nothing but recharging, or you can say this is working as an electrolytic cell. So what will be the reactions? The reactions will be, first of all, let us start with oxidation. What will be your oxidation? So oxidation simply means it will be working as an anode. And what will be oxidation? So oxidation will be loss of electron. So oxidation should occur at a place where there was acceptance of electron in the galvanic cell. So electrons were accepted over here in the galvanic cell. So obviously in the electrolytic cell, electrons will be lost over here. So the reaction will be completely reversed. So what will be the reaction? This PbSO4 and this water will again come back. So you will be having PbSO4. You will be having 2 times H2O coming back. They will be getting converted into 4 times H plus they will be giving back PbO2 plus they will be giving back SO4 minus 2 plus 2 electrons. So the next will be reduction. And reduction simply means you will be speaking about something which is called as cathode. So this will be a reduction reaction taking place at cathode. So what is basically reduction? Reduction is basically gain of electrons. So obviously it will be taking place at a place where there was oxidation in the galvanic cell, and oxidation in the galvanic cell was taking place over here. So in the electrolytic cell it will be a reverse, that will be an acceptance of electron. So what will be the reaction? PbSO4 will be going back and it will be dissociating into Pb2 plus and SO4 2 minus, from where Pb2 plus will accept an electron and will go back. So the reaction will be PbSO4 accepting 2 electrons and getting converted into Pb, and where Pb was +2 oxidation state, and this electrons will be going to Pb, and what will be left behind will be SO4 2-. So this is the cathodic reaction, and simply that's it. So in short, what will be the overall reaction? If you look carefully, the overall reaction, if you look carefully over here, PbSO4 plus 2 electron giving you Pb plus SO4 2-, and it is simply a reverse of this reaction. If you look over here, PbSO4 plus 2 water giving you 4 times H plus PbO2 SO4 2- 2 electron, it is simply nothing but this reaction. So if you remember one of the reaction, if you remember anode over here, you can simply remember cathode over here. If you remember cathode over here, you can simply remember anode over here. So they are simply reverse. So what exactly is happening overall? In the galvanic cell, Pb will be coming out, forming PbSO4, electrons will be traveling over there, hydrogen will be coming, reacting with PbO2, giving you water and sulfate. So what will be in the electrolytic cell? Complete reverse. PbSO4 will be going back, getting converted into Pb, and sulfate will be left behind. Over here, PbSO4 and water will be coming back, giving you Pb oxide, and H plus will be again formed, losing back electrons. So this is the overall working of lead accumulator battery. Charging and discharging questions are often asked in your board exam, where you need to write about oxidation, reduction, charging, discharging. Diagram is not usually asked, but do by heart these reactions. They are very important. So the next will be, we are talking about will be the fuel cell, which is the last cell in your syllabus. So let's talk about fuel cell. Now the diagram given in your textbook is a bit complicated and difficult. So let me simplify this diagram. Let us consider we have got 2 electrodes over here. This is the first electrode. Let me say this will be the second electrode over here, and these 2 electrodes will be containing KOH. So let me say this will be KOH, which will be placed between these 2 containers. Let us say there is an outer jacket from where you can pass oxygen over here. That will be O2. That's nothing but oxygen, double bond oxygen. And let us say this is the second inlet from where you can pass hydrogen. So this will be hydrogen bond hydrogen, hydrogen bond hydrogen. What you will be having will be KOH over here. And let us connect these 2 containers, these 2 electrodes by a rod. This will be by a wire, and this will be a bulb, which will be an indicator whether the electrons are flowing or not. For sake of simplicity, let me write KOH 4 times. So this will be OH minus K plus. This will be OH minus K plus, OH minus and K plus. And again it will be OH minus K plus. Now I am writing it reverse purposely. What was the reason? The first reaction that will be taking place over here will be an oxidation. Now oxidation simply means it will be an loss of electrons, so it will be working as an anode. So the first reaction will be taking place where the hydrogen is coming in. The 4 OH minus will go and they will attack these H2 molecules. 2 H2 molecule, all the 4 hydrogen molecule, all the 4 hydrogen atoms will be losing up their electrons, and hence 4 electrons will be lost, forming 4 H plus ion. This 4 H plus ion will combine with 4 OH minus ion, giving you 4 times water molecule. That will be H2O, that will be H2O, that will be H2O, that will be again H2O. So you will be getting 4 hydrogen hydroxyl ion reacting with 2 H2 molecules, giving you 4 electrons and 4 water molecule. So the reaction will be 2 times H2 plus 4 times OH minus, giving you 4 times H2O plus 4 electrons. These 4 electrons will obviously be traveling from this bulb, and they will be coming over here. Now here oxygen will combine with 2 of these water molecules. These 2 water molecules will combine with oxygen in the presence of 4 electrons by taking up 4 electrons and giving back 4 OH minus. So what will be the cathodic reaction? The cathodic reaction simply means it will be reduction. So this will be reduction reaction, and this will be in the presence of oxygen, plus this will be in the presence of 2 times H2O, plus this will be 4 electron, giving you back 4 times OH minus. So now if you simply look over here, 4 times OH minus were used and 4 times OH minus are replaced. So there is no effect on the concentration of KOH placed over here. So what will be the overall reaction? The overall reaction, if you look over here, the OH minus ions are getting cancelled. 4 electrons are cancelled. Now if you look very carefully, this 2 H2O and 2 will be getting cancelled. So what you are left behind will be 2 times H2 plus O2, giving you 2 times H2O. So the only byproduct formed over here will be a water molecule. This is also one of the reasons why fuel cells are mostly preferred, and hence this fuel cell will be called as H2 H2O2 fuel cell. Since hydrogen and oxygen are used over here as a fuel, as we all know, hydrogen is a combustible gas and oxygen supports burning, hence it will be called as H2O2 fuel cell. The only drawback over here will be efficiency is not as per the theoretical value. Efficiency is little less. There are many advantages of using a fuel cell. This was first used in your space programs. Hydrogen oxygen fuel cell has also gotten a benefit because the only product formed over here will be water molecule. There's no side product, hence it is environment friendly. So please do read about the drawback, the applications of hydrogen oxygen fuel cell. It's one of the most important question in your board exam. The diagram that I have drawn over here is a rough diagram, just it's a schematic representation to simplify the reactions, and the reactions are only two. So if you remember all this stuff, you will definitely not face any problem in electrochemistry. I hope this video was useful, and I hope you will remember the cells and the reactions, the tricks, how to by heart them and to simplify them. Thank you very much.